Hey guys, today what we're going to learn today is the EV3 Sumo wrestling programming. First off, we want to get our Lego Mindstorms program up on our computer and open a new project with this plus sign right here, which is the quickest way to open a new file. Let's name this Sumo, because that's what we're doing today. First off, let's grab a loop from our orange section right here. And now a switch, which is actually a new block that we haven't learned yet, but today we'll learn its utilizations. Now from this switch, we can go to a color sensor, compare and reflected light intensity. Right now we have a measurement right here. We want it to measure our black reflected light intensity. Right now, what you can do is go to our port view, and which is on the third block on the top, and we can see our sensor at the second sensor port. And it will show you the reflected light intensity. Right now, let's find a black surface to measure our light on. And let us put the color sensor onto our black surface, and we can see that the reflected light intensity is actually 2%. 2% of the light is reflected, and we can switch it to 2 or 3 because it is right in between that value. Alright, now let's look for a white surface to measure, and make sure you aim it correctly onto our white surface. Now we have a 69% of light reflected. Now let's do some math. First off, when we did 2, which is our black surface, and let's add 69, which is our reflected light intensity when we do white, and we get 71, and divide it by 2. There we get 35.5. All mental math, guys. Stay in school, learn math. Math is cool. Alright, now let us design our program. Right now, let's set our reflected light intensity so when it is greater than or equal to 35.5, which is the measurement in between, or which is 2 plus 70 plus 69 equals 71, and then divided by 2, you get 35.5. And if that's true, if the measurement is greater than 35.5, we want it to be on repeatedly and keep on charging on. If it's not, then it will go to the bottom one where there is an X, and we can make it go backwards and turn. This is just due to the nature of sumo wrestling for EV3. As you can see later as we demonstrate, everything will become more clear onto why we are doing this. And as we want it to turn backwards, we want the power to be negative and not too much. Rotations, let's do 0.5. And again, you can play around with these numbers, but first let's get into what the Sumo EV3 Sumo game is actually about. Now after we go backwards, let's turn around. For turning, I recommend Move Tank, where you can choose the power of both the left and right motors to make a more accurate turn. Let's do 50 and -25 for our B and C motors respectively. This means our left motor or B motor is going to go forward 50 and our C motor is turning backwards. This will make our whole robot move right or counterclockwise. And let's set that rotation to 1.5. Now let's save it to our robot. Now let's press download and let's go try it out. As you can see, this is the movement of our robot. When it hits the black, it will back up because it's sensing a color less than 35, which is less than the white surface. And now let's go back to our program, and let's try a new program. If we have a move steering or motor off at the front of our two moving blocks, this means our motors will turn off first and the next two blocks will start playing. Let's set this as Sumo test, as it's a new experiment that we're trying out. Now let's try this out and place it in the correct position, and let's start it. It's essentially the same, but the motors will register as turned off. And now we've completed our video today, and I fell off the chair. Thanks for watching, everyone.